Okay, pre-calculus kids, we're moving on to section 8-4. 8-4, and we're going to do the solving of trig equations. I'm on page 17 of our note packets. And basically, we have one goal today. We're going to learn how to solve the basic trig equations. We take what we learned in 8-1, 8-2, 8-3, all that simplifying and using all the little identity sheet and stuff like that. Just made me think of it. I got to get my identity sheet out so I have that ready to look at. Holy cow, look at that mess. All right, but just as a quick reference, I don't want to use an identity the wrong way. We're going to make solutions, and I'm going to set the rule out right now. So there's all sorts of ways you can do this. You could say it's for, let's say we solve it and the answer was 30 degrees. Or if it's in radians, pi over 6 radians. Some are in radians, some are in degree mode. The answer would be here. And then also when you go full circle and you come all the way around, so that'd be 360 plus 30, that'd be 390. Or if you were to go backwards, negative 330. And so there's multiple answers. Our answers, just for what we're doing, so that we don't have to worry about the multiples, how many circles forwards or backwards are included. If we are talking about degrees, we're going to use x. Anytime we see x, they're talking about it in degrees, and we'll say it's good. Just give me the answer or answers. Sometimes there's multiple answers between 0 and 360. Or if they use theta, we'll assume it's in radians. And we'll say it's between 0 and 2 pi. Just tell me the answers on one revolution around the unit circle. But that reminds me, if you're not good with it, and you should be by now, but the unit circle makes a comeback now. So you got to know your unit circle. Know that unit circle stuff. So let's say solve trig equations. Isolate the trig function by using algebraic techniques, stuff that we've always done. Here's what they mean by algebraic techniques. Determine the angles that satisfy. We've done a little bit of this. We've done the last part of this in earlier lessons. I'll get to that in a minute. What they mean by, use some algebra techniques. The rule in algebra is, hey, get x by itself. But with this trigonometry stuff, our rule is going to be combine like terms, but let's get sine x by itself. Get sine x all by itself. So what do you got to do? We're going to add 1. I got 2. Sine x is equal to 1. Divide by the number 2. Sine x is equal to 1/2. Now this falls back on a lot of things that we did in chapter 7. And this is what I mean. We're like, it all comes together right here. In chapter 7, I gave you problems like this. I said, hey, what answers would tell me that sine x is equal to 1/2? It's equal to 1/2. Well, you have to think to yourself, well, y is the sine value, right? Y is positive, so it's in quadrants. I'm not even thinking right. Quadrants 1 and 2. Quadrants 1 and 2. 1/2. Short leg. God, put it all in one word. Short leg of 30, 60, 90 triangle. So you got to remember these problems. We get a little circle like this, and you think there might be a circle drawn or not. But the y number, we're only going up 1/2. And so that's going to be here and here, 30, 60, 90 triangle. Reference triangle anyway. So that's got to be 30 degrees because this would be 1/2. This has to be 30 degrees. This would be 1/2. So one angle is definitely, x is 30 degrees, but there's another answer. And I don't mean spinning it all the way around and landing here again. That is, in other trig classes, that's going to be more answers. But the other answer is going to be all the way to here. That's a 30-degree reference angle. 30 degrees before you get to 180. That's 150 degrees. We've done these problems before. So when they came up in I think chapter 7, I don't think chapter 6, I was prepping you. That was just sort of prep work leading up to doing this stuff today. All right, so this one, and they used x. So anytime when they use x, we're going to use the degrees. Anytime they use theta, we're going to use radians. So same kind of work, but we use radians. Let's get sine theta by itself. Subtract the square root of, it equals negative sine theta. I wasn't thinking. We got to combine like terms. What we got to do. Let's add sine theta this way. All right, that would give me 2 sine thetas plus square root of 2 equals 0. Now subtract the square root of 2. Sine theta equals negative square root of 2 divided by 2. All right, so we get sine theta by itself, and it equals negative root 2 over 2. Again, think unit circle stuff. Think unit circle stuff. So if sine theta is negative root 2 over 2, we know one thing, not more than one thing. We know y is negative, which means for us quadrants, when the y is negative, quadrant 3 and quadrant 4 is when the y is negative. When you see square root of 2 over 2, you got to think 45, 45, 90 reference triangles. 45, 45, 90. Those are the ones that go straight through the center of a quadrant, right through the middle, making 45, 45, 90 triangles. They want this in radian mode. So remember, radians, when you're talking about 45-degree angles, that's pi over 4. So it goes pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So one of the answers is 5 pi over 4. Then it's 6 pi over 4. That would reduce to 3 pi over 2. And then 7 pi over 4. Or you can think backwards. This is 2 pi. So you can think of that as 8 pi over 4 and go back 1, 7 pi over 4. But theta is going to be equal to 5 pi over 4 and 7 pi over 4. 5 pi over 4 and 7 pi over 4. Example 3, same idea, now with a tangent problem. I'm going to add the 1. 3 tan squared x equals 1. I'm going to divide by 3. Tan squared x is equal to 1/3. All right, so that's a little bit different kind of problem. We didn't have anything squared, but it's the same thing. If it said x squared, what would we do to both sides? Square root it. Well, we're going to do the same thing. We're going to square root both sides. So now what happens is we get just tan x here. But this side needs plus and minus. Oh boy, that's going to lead to a lot of answers. Square root the top and the bottom. You get 1 over root 3. We got to rationalize the denominator. All right, and so we get plus or minus square root of 3 over 3. Now, it probably helps before you rationalize it to sort of think of it as 1, like this right here, 1 over root 3. Remember that tangent means opposite over adjacent. On our unit circle, it means the y number over the x number. And that might be where it gets to be more easier to think about it. Yeah, it equals plus or minus root 3 over 3. But plus or minus root 3 over 3, if you don't rationalize it, looks like this. On a unit circle, that means the x number is going to be the square root of 3. The y number is going to be a 1. That would mean, how do I want to phrase this for you guys so you can put the whole idea together? They've already divided. So you got to think you see the root 3? It's a 30, 60, 90 triangle. Okay? 30, 60, 90 triangle is usually like this, where you got our unit circle, the radius is 1. The short leg is half of that number. And then this is that number, 1/2 times square root of 3. So you get square root of 3 over 2. The square root of 3, that's the long leg. The 1 is not the hypotenuse, but it's the short leg. Both of these are supposed to be divided by 2. Like instead of 1, it's supposed to look like 1/2 divided by square root of 3 over 2. Those 2's would cancel each other out. You get 1 over square root of 3. Now I'm really talking some simplifying fractions and stuff like that. And it might get confusing, but that square root of 3 is the long leg. That 1 is an indicator of the short leg, because that's going to be a 1/2 and root 3 over 2. It's important to remember with tangents and cotangents, especially. But it's also plus and minus. Holy cow, that's going to be every time the y is the short leg in every quadrant. in all the quadrants when y is the short leg and when x is the long leg. These are the root 3's, negative root 3, positive 1/2, negative 1/2. Now, to get the solutions that we want, we got to think of what angles are these? Well, it's x, so we're going to use degrees now. This is 30 degrees. If I rotate it all the way to here, oh, I lost my light. Oh, womp womp. Oh, I lost all the juice. Oh, hopefully it comes back. Let me keep going here. If I go all the way to here, it's 150 degrees. If I go 30 degrees past 180, I'm at 210 degrees. Go here to here. Then if I go all the way around 30 degrees short of a full circle, 330 degrees. Those are all the answers to that problem. 30, 150, 210, 330. Why so many answers? Because of this plus minus. So it could be a positive 1/2, positive 1/2, a negative 1/2, positive 1/2. I'm sorry, that should be a negative 1/2 over there. Positive root 3, negative root 3. It's plus or minus root 3's. It's plus or minus 1/2 all the way around the circle. All right, let me check the back page here. All right, I'm going to pause it right here. I've got just 3 problems left. I got 3 problems left, 3 more examples. I'll save those for video number 2. Click over to video number 2 to see the back page of the notes.